In this video, we are starting to get into a very important application space in AI called natural language processing. So in this kind of space, we are obviously the space is vast. So we were not going to treat everything that it is to be treated. It's actually quite exciting. But we are going to hit some main points so that we can all understand the basics and some kind of foundations. We will start with understanding about the embeddings. Then we will proceed to use the neural architectures like the recurrent neural networks in the form of LSTMs that we have seen in an earlier video, and initially start with those and understand the kind of what is called attention, the attention mechanism specifically for sequence-to-sequence problems. And then we will be looking at language models and finally look at the transformer architectures. And these architectures are going to be motivated by some notebooks as well. Not only those transformer architectures, but also other architecture has to do with sequence-to-sequence modeling and LSTMs. So in a similar setting that we have seen in another video where we actually were looking at the sort of structure of the agent as it is acting in an environment. The chatbot will take the form of an agent that is evidently will be acting in an environment which is obviously different than a physical robot. Definitely this environment is effectively the users. Let me just draw them like this and write them as, let's say this chatbot is a bot that it will be interacting with users of a customer service. So the environment are the users of customer service. And not only that, but also it will be and this interaction will be in a piece of software that is a chat application. I mean, famous chat applications such as Discord. I guess everyone has some familiarity with Discord or Slack. So that is basically the environment. And as we have seen previously, this environment will have some form of a state. So the state of the environment is fully observed in this case. In what sense that what the users are actually typing towards the bot, asking the bot questions, or are issuing kind of queries into this bot are fully observable by the bot. And the agent, this natural language processing agent, in this case, will be drawn now on the sort of left side over here of that environment. So the equivalent to the perception subsystem that we had in robotics, over here we have a subsystem called the parsing subsystem, and evidently it is receiving some form of textual or in many instances also a combination of text, images, and even video, although most of the bots that we will be dealing with in this lecture are going to be associated with text. Okay, so the parsing stage, so we'll see exactly what the parsing stage kind of includes. If I can draw the kind of the rest of the block diagram, then the text is actually coming in, it is parsed, and this subsequent kind of stage is called the analysis or planning, and and planning kind of stage. And then finally we have some form of natural language generation. Where we respond back to that environment. Okay, so these are basically very high level sort of diagram that represents the chatbot application. And so what is happening at every kind of stage largely defines the sort of stages also of a typical NLP kind of pipeline. So the text that it is inserted by the users the first stage is segmentation. So for example, in our site over here, we have actually given some examples of what is the segmentation. So effectively, let's take a sentence. London is the capital and most populous city of England and the United Kingdom. During that kind of stage, a paragraph that the user may have inserted, it can be segmented into, in this case, a sentence. So the paragraph could be pretty sizable, and that segmentation stage is just gives us, if you like, a sentence from the beginning of the sentence until the full stop. So that is an example of segmentation. The subsequent kind of stage is called tokenization. So in this kind of tokenization, we are converting the segmented, if you like, text into tokens. Now there's a much deeper discussion to be had as to how we actually go about doing that, and we'll provide some kind of a few ideas about how to do tokenization. So let me also write down that kind of stage. So tokenization. Okay, and in this specific simple setting, we can imagine tokenization to be a whole word tokenization plus any symbols that we have, like the full stop over here. So that is basically a fairly easy in this specific example sort of stage. Then we have other stages that are helping us, if you like, understand what is being typed. And so one of them I wanted to mention is, the so-called part of speech tagging. The part of speech tagging. And in the part of speech tagging, what we actually can see is that is the following is happening. So every single of the tokens is being classified to be a noun, a verb, a conjunction, an adverb, an adjective. So all of these are helping us to understand exactly what the the sentence is all about. And then we have some other subsequent stages called lemmatization, which is some kind of a simple normalization stages, stop word identification, so that we can definitely have an idea about where this sentences are ending. And then we have some more advanced tasks which I wanted to refer to. And then the first one is called dependency parsing. And in the kind of dependency parsing, we have our goal is really to form a tree. And in this tree, what we do is at the root node, we assign a single parent. One of the words is assigned to be the parent, the root node of the tree. In this case is B. And we also, in this case, we're also predicting what type of relationship is the other tokens with respect to this kind of root node. So in this case, the relationship is with London is subject, in the relationship with capital and is attribute, and so on and so on. So this type of algorithms or predictors are starting to become a bit more involved, and so we actually have to use, for all the stages, we are going to be using certain libraries. There are historically in the natural language processing space, there are two libraries. One of them was called NLTK, and it was kind of a bit more research oriented. But over here, we are going to see a demo from another library called Spacy. In this example, you can see that the root node is the verb having. And the relationships that spaCy can predict are actually here based on an existing model. And I think it's notable the compactness of the API for this kind of library, how quickly you can actually see and visualize exactly all the dependencies that spaCy is able to predict. And of course, we have many other libraries that we will meet gradually in this and other videos. So we have dependency parsing. And we have also named entity recognition, or NER. And here is an example of named entity recognition that we can actually see here. So we have if you like, in this kind of paragraph, the purpose is to identify and classify by classification what is really the category that corresponds to every word, at least those who are words that are correspond as the so-called named entities. In this case, 2019 is obviously a date, it's classified as such. There are obviously the United States is a geographical entity and is classified as such, and NYU Grossman School of Medicine as an organization, and so on. Now, this person is Devin Mann is a person, and there are obviously also some mistakes, as you can see, and in this case, the profession of the person, which is a medical doctor, is misinterpreted as a geographical entity, and COVID-19 is called an organization. And we can have, of course, other errors, and all these errors are originate from the statistical nature of these predictors. And to close the discussion about what other stages we can actually see in this kind of parsing subsystem, I think it's worthwhile mentioning about coreference resolution, because it is really one of the more complicated tasks, and people are actually humans are actually very capable of establishing some form of relationship between, let's say, it and London, but coreference resolution, evidently, that relationship has to be predicted by an algorithm, a neural architecture. And so here we see another example of that. So in this case, we have a sentence: my sister is swimming with her classmates. They are not bad, but she is better. Let's stop here. So the they is evidently associated with classmates, and the here is associated with the sister, and so on and so on. So the coreference resolution is also helping us to understand some of the language which is behind, if you like, the input text that came to this kind of chatbot. And with that, we kind of conclude the discussion about the parsing subsystem. And we can actually move into discussing this analysis and planning. And in this case, what we have here, if I may just go back to here and mention quickly the coreference resolution that we have seen. So if I may actually do something like this to indicate that this part of parsing. And in the case of analysis and planning, we should be associating with this kind of stage with a database that we will call knowledge base. Now, we've seen the term knowledge base in another video as part of logical reasoning, but this is a bit more conventional kind of database. It's not constrained from the propositional logic and the various kind of logical sentences that are there. Is a relational database or a NoSQL database, as are also known, or document-oriented database. And this kind of analysis over here, we may actually see use cases associated, let's say, with, if I may open up some space, the sentiment, let's say, sentiment analysis. We may actually need to predict as to whether this customer is angry, happier, is, what is this kind of psychological state in order for us to react kind of appropriately. we may actually do power use cases out of the system that are associated with semantic search. And in semantic search, we are effectively trying to find relevant responses that the chatbot will be able to select from and send as part of this kind of response. So in many simpler kind of chatbots, some of these responses are already structured, and then we can, with semantic search, we can actually find some additional information or retrieve some kind of additional information necessary for the subsequent block to be able to form a natural language response. As an example, we may the customer may be mentioning the model number or something that can identify, if you like, a product or a service. And with semantic search, we actually can look in the database, in the knowledge base, and retrieve back some more information about this kind of product. This could potentially acting as a prompt for the subsequent case of natural language generation, the subsequent block of that, the energy block, which of course over here we will see that a lot of things are happening, but definitely we will have to have the so-called language model. And as of recently, this is qualified with kind of foundational models called large language models. Well, it doesn't really have to be large. It could be a language model that has been constructed for the very specific narrow domain that the bot is able to respond to the customer. And we may actually have sequence to sequence models over there, or associated with responding to customers potentially in multiple languages. So let me mention that. And so on. So the natural language generation is kind of a rich space that we actually can borrow from a lot of the stuff that we'll be discussing in this video series on natural language processing.